Sir, in the last videos, I think we started different types of sorting techniques manually, how we can able to sort. Okay. Sir, for that, the first sorting algorithm which we discussed is nothing but a bubble sort. So I explained very clearly how this bubble sort is going to work. We have seen the implementation of a bubble sort in ascending order and how to sort the data in the descending order also I explained very clearly. Sir, the problem with bubble sort is, do you know, if you have a bubble sort, okay, if you are using bubble sort for the sorted elements, means what you can see, if the elements are already in sorting order, first we will compare the first element with the second element. See, if the first element is the largest, then only swapping must be required, right? Here no swapping, and here we will compare 2 with 3. Here also no swapping. Sir, here also we have to compare, here also no swapping, here also we have to compare, here also no swapping. That means in the first comparison, in the first iteration, sir, if no swaps are required, no swaps are there, then immediately I will stop. The list is already in sorting order. This is nothing but the improved version of a bubble sort what we have. Okay. So improved version of a bubble sort, improved version of a bubble sort. Sir, what is this improved version? Very simple. If already list is in sorting order, why we need to sort again? So we can stop that, right? So for that I am going to use this sorting technique, sir. How I am going to ignore that? You can see, sir, I have bubble sort ascending order is there. Sir, I am going to give the numbers here. Let us take 1 2 3 4 5. Okay. Sir, I am not taking like this, so I am not taking any random elements. Now you can see what is output that we are getting before sorting and after sorting same. Sir, can I say, in the first iteration, that is, this is the first iteration, when first iteration is doing, I am going to take swap is equal to false. There is no swapping is required. Whenever we are doing the swapping, then I am going to take swap is equal to true. Yes, swapping is done like that. And after completion of the first iteration, if the value of swap is equal to false, that means if no swapping is performed at first iteration, directly I am going to return. That means what? It won't execute for remaining cases. In this example, how many elements are there? For example, if 10 elements are there, we are taking the first iteration. In the first iteration, I am going to assume there is no swapping. Then I will take remaining all the elements and I am going to compare every time. Sir, if already this second element is larger when compared with the first element, swapping won't be there, right? In such cases, what will happen? This statement never executes. Okay. If you want, you can see L of j. Sir, j value is in this example. So if you take j value is equal to initially 0. So we are taking L of j, that is nothing but L of 0. Okay. Sir, is it greater than L of 1? What is L of 0? 1. Is it greater than 2? Condition not satisfied. That means this condition is not executed. Then second time, sir, what is the second element? 2 is greater than 3. Condition not satisfied. 3 is greater than 4. Condition not satisfied. 4 is greater than 5. Condition not satisfied. Have you observed? If all the conditions are not satisfied, then immediately it will come out from this loop and it has to go for next iteration. Even though you are taking next iteration and useless comparisons, right? That's why I'm going to check whether swap is equal to false. That means if all the elements are in sorting order, no swapping is going to be done. In such cases, come out from this, why unnecessary running the loop? This is nothing but what we have in the output. You can't see anything, but real time, sir, you are going to improve the performance. Sir, everyone got clarity about this? Please confirm. Yes, I need a response from everyone. Please confirm. Is it clear for everyone? Right. The next sorting algorithm, what we have here is selection sort. What is the next sorting algorithm? selection sort algorithm. What is this selection sort? Very simple. I can say it is going to take, okay, it will take how much time? Big O of n square time it will take. As usual, it is going to take big O of n square time. Then, sir, it will occupy less memory bytes. It will occupy less memory bytes, okay, when compared with previous algorithms. Okay, like whenever if the numbers are not in a proper position, so it is going to do some kind of a shifting, right? For example, so if you take 5 1 3, okay, 2 4 something like that, and then 6, we are going to swap and we will interchange, right? Such type of overrides, less number of overrides is going to be done in this selection sort, and it is called as in place sorting. In place sorting in the sense what, sir? No extra, no temporary list is required. In the same list only that modification is going to be done, and it is not a stable algorithm. It is not a stable algorithm. Not a stable means what? For example, if you take bubble sort, if you take bubble sort, consider we have 90 is there, so 60 is there, okay, next and after that 90 is there, and 70 is there. Sir, in the bubble sort, what we are doing, please observe this point. This is the first 90 and this is the second 90. Sir, in the bubble sort, what we are going to do? Sir, we will take first element bubble with second. Is the first element is greater than second element, so movement must be done. That is nothing but 60 will come here, 90 will go here, 90 is already there, 70 will be there. Sir, this is first 90 and this is the second 90. Then 90 and 90 compare, so nothing is required. Then this 90 and this 90 we are going to compare. Sir, what will happen? So here shifting is going to be done, right? Sir, 60 90 will be there, and then 70 will come here and 90 will go here, okay, like that. Then again what we have to do, we need to compare this, like that we are going to move. Sir, here we can't give guarantee for the order. Maybe in this case we are getting the same order. If you take different elements, you won't get it. So means what? In which position it is available, in the same position if you are getting after sorting also, I mean same order if you are getting, I can say those are nothing but what? Stable sorting. But here our selection sort is not stable. Of course, next we are going to see some other sorting technique which is stable. Okay, sir, how this selection sort is going to work? Very simple, sir. First we have to find out, sir, first minimum, okay, minimum element, first minimum element, so in list, and move to the, okay, move to the first location. We have to find out the first minimum element in the list, and we have to move to the first location. Then find out second minimum element in the list and move to the which location? Second location. Like that we are going to do. Okay, this is nothing but how selection sort is going to work. But don't worry, I will take one example, I will demonstrate. Sir, I am taking one simple example like this. Okay, this is my list where I have the elements like 5 3, okay, 5 3 1 4 2, like this we have. Sir, what about indexes? This is 0th index, this is a first index, second index, third index, fourth index. Please observe this terminology carefully and see what is happening here. Sir, first step I am going to take, first step I am going to take I is equal to 0. I is equal to 0. Sir, I am going to consider minimum index is equal to 0. What is the minimum index? 0 is the minimum index. Sir, what is the element available here? 5. Okay, the element is nothing but what? 5. I will compare this 5 with 3. Sir, is 3 is less than 5? Yes, 3 is the less than 5. That means this is not the minimum element, this is the minimum element. So that minimum element index is 1. Okay, that means as of now among these two numbers, in which location the minimum element is available? First location. This process we have to repeat. Next, what is the next element? 1. Is it less than? Minimum index is what? 1. In first location which element is there? 3. Is 1 is less than 3? Yes, that means 3 is not the minimum element. the element which is available at a second location is the minimum element. Okay, sir, now take the next element 4. Is it less than second location value is 1? Sir, is it true? No. That means, so 2 itself is the minimum index. Then take next element 2. Sir, is it less than second location element is 1? No. Sir, that means what? Minimum index is nothing but 2 only. In second location, which element is there? That element has to be swapped with 0th location. Okay, so here 5 will come and here we are going to get 1. This is the first iteration, sir. Now I am writing the updated list. Observe carefully. Sir, we are going to get 1, 3. Okay, so 5 and then 4 and then 2. Like this we have. Sir, what about indexes? This is 0th location, first location, second, third and then fourth. Sir, which iteration we completed? I is equal to 0. Now we have to repeat this for I is equal to 1. If you are clear with the first case, then I will explain the second case, sir. Sir, second iteration also I will explain. Please confirm, is this first iteration, is it clear for you people? Right. In the second iteration, what we are doing, I am going to assume the minimum index is nothing, but already this element got sorted. So minimum index is 1. So which element is we have to take first? 3. Sir, is 3 is less than minimum index is 1. Condition not satisfied. Okay. Then take the next element 5. Is it less than the element which is available at minimum index? No. That means this is the minimum element. Next, take the next element 4. Sir, is it less than 3? No. Sir, next take the next element 2. Is it less than 3? Yes. That means minimum index is not 1, 4. Sir, the total list got completed. This position we have to interchange with 4. Have you observed how you are interchanging? I with minimum index. Here also I with minimum index. Like this we have. Then which values we are going to interchange? Here 2 will come and here 3 will come. This is nothing but another iteration. Sir, next what will be the next iteration? So which elements are sorted? 1 and then 2 sorted. Then 5, 4, 3 is there. We have to apply this one for this. Okay, here these two are going to be interchanged. Okay, these two are going to be interchanged. Maybe internally some manipulation is going to be done. Sir, finally if you do all the iterations, we will get 1, 2, 3, 4, 5. Sir, I think if the concept is clear for you people about the selection sort, I will implement the program. Is the concept is clear? Right. So let us go for, I want to implement this selection sort in ascending order, sir. Okay, I want to implement selection sort. I want to implement selection sort implementation in ascending order. Let us see how you can able to do this. So I am going to take selection sort. Right. Listen. First, we are going to find out length of the list. Then, for each I value in the range of n minus 1, for each I value in the range of n minus 1, you are going to take minimum index value is nothing but I. So how many times the loop is going to run? If a list is having 5 elements, so we want to compare last element with the remaining elements, right? That's why I'm going to take up to last before element. Minimum index is 1. So now I'm going to take for each j value in the range of, for each j value in the range of, sir, I plus 1 to n remaining elements I am going to compare. How to compare? Is your L of j is less than L of that minimum index location. If it is true, then your minimum index value will become j, sir. Like that we have to do. Sir, after completion of this loop, first iteration, we have to swap L of I with L of minimum index. We are identifying the minimum index, right? That minimum index value we are going to exchange with L of I. That's all. This is nothing but what we have. If you run the program, automatically the data is going to be sorted in ascending order. You can see before sorting, these are the elements, and after sorting, these are the elements what we are going to get. Okay, this is about selection sort implementation in ascending order. If you want to do this selection sort in descending order, so what modification we have to do? The program is the same. The only change is nothing but in the place of this ascending, I am taking descending, and here also I am taking descending. Sir, instead of finding minimum index, what you have to find out? Maximum index we have to find out. How you will get that maximum index? Very simple. If the element is greater, we will get maximum index. That's all. Now run the code. Max, here also max index. Now you can see. Sir, is the data got arranged in descending order or not? Yes. This is the way how we can able to sort the elements in ascending order and descending order by using selection sort. Sir, everyone feeling comfortable up to this whatever we have? Clear, sir? Sir, please confirm everyone.
Comparison of cell bubble sort or selection sort, which performed with fast
Sir,
in both sorting bubble sort or selection sort, which is doing execution faster.
selection sort. Why? Because in the bubble sort, every time we are comparing only 2 elements, right? In the first iteration itself, you are going to compare first element with the second element with the third element with the fourth, like that we are going to do. Then same process we have to repeat again. But in this case, what we are going to do? We will identify the minimum element, but almost the loop is going to run with the same time. But just I have given in the introduction, sir, it is going to take less memory writes. That means when you are doing swapping, less memory writes it is going to do. When we are going to swap, in this place only we are going to swap. But if you take previous bubble sort, every time we are going to swap, right? So this is called as overriding. How many times you are going to do? That is less when compared with bubble sort. Got it, sir?
But it's
Yeah. Example 9745, or if you take here 1918. First time in the bubble sort, these two elements will be swapped. So next 19 will come, 19 and 63, no swapping. So then 6335, swapping must be required. Like in the first iteration itself, maximum swappings we are doing. But in the selection sort, we will take the first element, we will compare with all the elements, and we will find out the minimum element. That element will move to the first step. Only one step. This is called less number of memory writes. Got it? Right. The next one is nothing but insertion sort algorithm. So what is mean by insertion sort algorithm? Very simple. Sir, it is also going to take. Okay, better to copy from the previous sorting because maximum points will be. Yes, it will take big O of n square. Sir, it is nothing but less memory writes. No, there is no less memory writes. It is in place. That means what? No temporary array is required. And it is a stable sort, sir. It is a stable sort algorithm. When we have a duplicates, then it is going to work. And this sorting is recommended for I can say, if you have less number of elements, so then it is a recommended like this we have. Sir, what about the process? Very simple. We will divide, okay, we will divide the list, we will divide the list into two parts. In the first part we will place, okay, we will place so all sorted elements. And in the second part we are going to place, we will place so unsorted elements. Like how it is going to be done, I will demonstrate with example. First see the example, then you will get clarity. Right. Sir, observe carefully. I am taking some elements like 20. This is the first element, and 5 second element. Sir, please observe carefully. 40. So next I am taking 60. Next I am taking 10. Next I am taking 30. So my first requirement here is, see, I am going to take, I will ignore this, first element. I am going to divide the list into two parts. This is a sorted list. This is unsorted list. I will take one element from unsorted list and I will insert in sorted list in such a way that it should be aligned in a proper order. Where we have to insert this 5? Sir, can I say this 5 is going to come here? 5 followed by 20. Of course, we will write algorithm for that. And 40, sir, 60, and then 10, and then 30 will be there. So two parts are there. Here sorted list is there, unsorted. Now take the next element and insert in a proper location. So what will happen? Sir, 5 comma 20 comma so 40, and unsorted elements will become 60, 10, 30. So take the next element 60 and insert in a proper location, so that your next list will become, sir, 5, 20, so 40, so 60, then unsorted list will become 10, 30. Then take 10 and insert in a proper location. Sir, it will become 6, 10, not a 6, it is a 5, I think so. Yes, we are going to take a 5. Okay, so next 10 will come, next 20, next 40, next 60 will be there, after that 30. So take 30 and insert here, so that what will happen? So 5, so 10, 20, and we have to take 30 and 40 and then 60. Like that we are going to take. The people who are playing cards, so you people will get clarity on this, because so when you are playing the cards, you are going to use this insertion sort mechanism only. You will pick up the card from the table and you are going to insert in appropriate position. Sir, please confirm, is the diagrammatic representation of this insertion sort, is it clear for you people? Yes, please confirm everyone. Right. Now we will see the implementation. Okay. So I want to see insertion sort, insertion sort implementation, insertion sort implementation. Okay. So in ascending order, how it will be, I will demonstrate. Listen carefully. Sir, here I'm going to take insertion sort ascending ASC, and I will replace the name here. Then, sir, what about the code? First, I will write the code. For each I value in the range of, please don't take the 0th element, start from first element and up to length of the list. So what we have to do, we are going to copy L of I, the element available at ith position we will copy. Then j is equal to I minus 1 I am taking. Sir, until the value of j is greater than or equal to 0, and if your x is less than L of j, So we are going to move L of j plus 1 is equal to L of j, and j is equal to j minus 1. So after completion of this process, L of j plus 1, in that place we are going to copy x. But once if I explain with the diagram, then only you will get clarity. Just observe carefully. So here, consider I have the list of elements. Okay, like let us take the previous element only. Okay, previous elements, like we have 20 is there. Okay, next 5 is there, so next 40 is there. Okay, so next 60 is there, so next 10 is there, so next 30 is there. Assume like this we have some elements. Sir, what about its indexes? 0th location, first location, second location, third location, fourth location, fifth location. Observe carefully how it is going to work. So first time, what is the value of I? Since it is starting from 1, it will be 1. Then x is equal to, sir, L of I, L of 1. L of 1 is what? 5. I am going to store that value in x. Then your j value will become I minus 1. I value is 1. 1 minus 1 means 0. Sir, continue the while loop. Is 0 is greater than or equal to 0? Yes. What is another condition? X value, that is a 5. Your x value is nothing but what? 5. Sir, is it less than L of j, L of 0? Yes, 5 is less than 20. That means what? So we have to execute this while loop. L of j plus 1, j value is 0. 0 plus 1 will become 1. In that place, I am going to copy L of 0. So L of 0 will be copied to L of 1. L of 0 will be copied to L of 1. That means in the place of 5, you will get 20. Then j is equal to j minus 1. Next time your j value will become 1. Minus 1. Sir, if it is greater than 0, you have to run. Since it is not greater than 0, it will stop. Then at last, L of j plus 1. J value is what? Minus 1. Minus 1 plus 1 means 0. In 0th location, we are copying this x. What is the x value? 5. That we are copying here. Have you observed? Now can I say these two elements got sorted? Yes. But don't worry, I will explain how this 40 is going to be sorted. Sir, please confirm. Okay, let me complete that second iteration also, sir. So when I is equal to 2, what will happen? Your x value will become L of 2. Which element is there, sir? 40. Then what is the j value? Sir, your j value is I minus 1. 2 minus 1 means 1. Sir, is 1 is greater than or equal to 0? Yes. Then x value is 40. Is it less than L of 1? What is the L of 1 value? 20. Is 40 is less than 20? No. Condition not satisfied. Sir, then what will happen? Next time, okay, sir, next time it won't repeat it. Sir, L of j plus 1. L of j value is what? 1. 1 plus 1 means 2. In the second position, we are going to copy x as it is. So 40 will be updated with 40 only. Swapping is not going to be done. Okay. And when I is equal to 3, what will happen? Your x value will become L of 3, which is nothing but a 60. Okay. And your j value will become I minus 1. 3 minus 1 means 2. And it is greater than or equal to 0. X value is 60. And in second location, which element is there? 40. Sir, it is already in sorted. It is not less than. That means while loop is not satisfied. L of j plus 1. In third location, we are copying x. What is the x value? 60. That will be copied to the third location. Sir, I can say with these 3 iterations, the first 4 locations got sorted. Please confirm if you are clear with this. Okay, if you are clear with this, so I will explain. So one more iteration, sir. Please confirm is the concept is clear up to this whatever I covered.
Yes, sir.
Right. Now I am writing the code for I is equal to 4, which is very, very important. Listen carefully. So when I is equal to 4, what will be your x value? It is nothing but L of 4. That is nothing but 10. And what about j value? J value is I minus 1. 4 minus 1, 3. Sir, is it greater than or equal to 0? Yes. X value is a 10. Is it less than L of 3? L of 3 is nothing but what? 60. Yes, boss. It is less than 60. Then go to the next j value and check next j value will become 2. Is it greater than or equal to 0? Yes. Is the element L of x value, that is nothing but a 10, is it less than second element? No. Condition not satisfied. Sorry, condition satisfied. Then your j value will become, sir, is the condition satisfied? Yes. Whenever the condition is satisfied, we are doing some operation. What is that operation? So L of j plus 1. Here in this case, j is 3. 3 plus 1 means 4. In the fourth location, we are copying L of 3. In L of 3, 60 is there, right? This is 60 we are copying here. Okay. Next in this place, so L of 2 plus 1, 3. In third location, we are copying L of 2, which is nothing but 40. Like this. Then your j value is 1. 1 greater than or equal to 0. Condition true. Sir, x value is 10. Is it less than L of j? Yes, condition is true. Then we are copying L of j plus 1. That is L of 2 will become L of 1. Yeah, what is a L of 1? 20. That will be copied here. Sir, now what we have to do? Your j value will become 0. 0 greater than or equal to 0. Yes, condition true. X value is 10. Sir, is it less than? Is it less than L of 0? Sir, no. Condition not satisfied. That means it will come out from the while loop and L of j plus 1. J value is 0. 0 plus 1 means what? 1. In first location, we are copying x. What is the x value, sir? 10. That 10 will be copied here. Now see the latest list. Is it 5? Next and after that 10. So 20. So 40 and then 60. Up to this sorted, 30 is unsorted. Same logic we have to take. It will implemented in such a way that 30 will be inserted in between 20 and 40. Like that insertion sort is going to work. Sir, everyone feeling comfortable up to this? Please confirm.
Yes, sir.
Is it clear how it is working? Right. Now we will execute the code and we will cross check whether it is working properly or not. You can see all the elements in the list got arranged in ascending order. Sir, how to do this insertion sort implementation in descending order? It is very simple. If you want to sort this data in descending order, sir, just we have to take in only one condition we have to change. What is that condition? In the place of x is less than, take x is greater than, except that remaining things are same. Now see what will happen. Is the data got arranged in descending order or not? Yes. This is the way what we have. I think you people got very clear idea about how to sort the data by using bubble sort. So selection sort, insertion sort. Sir, clear up to this? Please confirm.
Yes, sir.
Right. So in the tomorrow's session, we will see the remaining sorting techniques. Like we have counting sort is there, radix sort is there, and quick sort, merge sort is there. Tomorrow I will cover all these sorting techniques. Okay. Right, sir. Thank you. See you on tomorrow.